Okay, this is following on from the video last time. It's going to be nonlinear graphs again, but this time we've been looking at the gradients of some graphs. Okay, so this is going to be dealing with how steep something is and giving it a numerical value. We know how to find gradients of straight lines, but we don't necessarily know how to find gradients of curves. Yeah, but it's still the same thing. How steep is something? Okay. We're still going to be using gradient as rise over run. Okay, here's a curve. Okay. Okay, once I've drawn that, we'll carry on. So the question is, what is the gradient of the curve of the function when x is equal to minus 6, x is equal to minus 2, and x is equal to 5. So what does that mean? Well, we've got this curve, and you can see if you were following the curve, the gradient changes. It starts off quite steep, then we get to kind of the top of the hill, and then we go down, the gradient gets negative, and then it gets smaller, and then it gets steep again. So the gradient of this function is changing. It's not the same the whole time. Okay. Right, so on the graph there, I've put the point x is equal to minus 6, and we're looking at what the gradient is there. Well, the gradient here, it's kind of flat. Okay? So it doesn't really have any steepness. So when x is equal to minus 6, the gradient there is 0. Okay, there's no steepness. Intuitively, you can think of that as having no steepness. Okay, moving on. When x is equal to minus 2, okay, it's quite steep and it's negative. If we look at when x is equal to 5, that's a bit less steep and it's positive. Okay, so we don't actually know how to find a value for these gradients, but we do know how to find the gradient of a straight line. We just use rise over run. And we're going to employ that method to find the gradients of this curve. Okay? So we can say that the rise is the change in y, so that little triangle means the change in. So if we're doing the gradient of a straight line, we can say the change in y divided by the run, which is the change in x. So the gradient, I'm going to write it like this. I'm writing it like this for a particular reason. So rise over run is the change in the y divided by the change in the x. Okay? In this case, in the example I've done, it's 2 squares up divided by 3 squares along, so the gradient is 2/3. Okay? Right, so what we do when x is equal to minus 2 is we draw a tangent to the curve at x equals minus 2, and that's what that light blue line is. It's a tangent. We're going to use that tangent, find the gradient of that straight line, and that's going to be the value for the gradient of the curve. Okay. So, we've drawn this straight line. We're going to use the rise over run method. The rise is negative 3. If you look at the scale, it goes down negative 3. And the run is 5 across. So the change in y divided by the change in x, the rise divided by the run, is negative 3 divided by 5. Okay, so that's about negative 0.6. Okay, if we go back to the first example, and we employ the same method, if I draw a tangent when x equals minus 6, which is that green line, that tangent is a flat line, okay? And the rise over run, well, there is no rise, the rise is 0, and that's why the gradient is 0 at that part of the curve. Okay, so the method, the intuition, and the maths both make sense together. Okay, looking at the final question then, at x equals 5, if we put that point in and we draw a tangent, okay, maybe you should pause the video there and see if your tangent and my tangent give you a similar gradient. Okay, drawing that tangent, if we find the rise and the run, okay, the change in y, or the rise, divided by the change in x, which is the run. If we look at this height here is 2.5. The run, okay, so we've got 2.5 for the rise, and the run, if we look at the run, it looks like it is 11, so we've got 2.5 divided by 11, if you do this in your calculator, or you simplify, you get 5 over 22, okay, 5 divided by 22 gives you an answer of about 0.23. So you can see it is less steep and it's positive. Okay. So I guess in summary, we are going to be drawing tangents to estimate the gradients of curves. Okay, so we draw the tangent, we know how to find the gradient of a straight line, we use that to find the gradient of the curve. Okay, and these are just estimates, they're not really they're not the exact gradient. But later, the next topic, which we'll try and start before the end of half term, is we're going to be using calculus, and this does allow us to find the exact value of the gradient. It does something a bit more mathematical than just drawing lines on graphs. Okay? So calculus will allow us to find ways to calculate the gradients using algebra. Okay, so we'll practice some of this in Monday's lesson.